Hey guys, my name is Emmanuel Sadikol and I'm doing Applied Computing in WT. Today, I'll be introducing the application that I built called BAP. BAP is a computer vision application able to detect players in a basketball. It was built using Python, OpenCV, and neural networks. Introduction. Today, most sports teams and players are investing a lot of their time in the idea of data-driven decisions in sports to help increase their level of performance and to increase their chance of winning a championship. So an idea popped up of creating a Python application that is able to take an input video to detect players, detect the basketball, and create a scoring system. I also wanted to explore and implement machine learning concepts into the project and play with cool APIs such as Post Estimator. Build process. We will extract frames from the input video using OpenCV and apply multiple image filtering. We will create a mask based on the HLB range threshold of color orange. From the mask, we will take the contours and apply the enclosing circle function. From the enclosed circle function, we can extract the center of the circle. We will use a circle to create a bounding rectangle, and then that rectangle will then be extracted as an ROI and passed on to the classification model to predict if the object is a basketball or not. I will then use the SSIM or the structural similarity index to measure the perceptual difference value between two similar images. I will then use this value to classify between a make or a miss shot. I will then use the YOLO object detection algorithm running in the OpenCV framework to detect the person on the court. I will also use the YOLO algorithm to extract the x and y coordinate of that person. I will then use Hogline transform algorithm with edge scanning line detection to detect the hard lines on the court. And from those detected lines, I will pass them as an input to a script that will detect the line of intersection between the 2 points. The line of intersection will be then used as 3D to 2D mapping. I will then use the calculated or extracted 3D x and y coordinates and warp it to the corresponding x and y coordinates on the 2D basketball court. Once the image is warped, I will apply a mask based on a color yellow HSP color range. Then using the map, I can map the position of the player to a 2D basketball image. All the following steps will then lead us to the final application clearly shown here on the left. Research questions. To detect the basketball, I've created a function. The function takes in a frame as an input parameter and performs multiple image filtering to it. It then calculates the HSB color range based on color orange, and then grabs the contour based on that mask. Then using the min enclosing circle function, we can extract a radius value. And if the radius is over 5 and less than 20, then we'll crop a copy of that object. The crop object will then go through a prediction model which will give us a label value of either a basketball hoop or a basketball. If the object is detected to be a basketball, then we will use OpenCV to visually label it. And then we get the following result. So how do we detect the basketball players? I will be using YOLO algorithm running on OpenCV framework. Following function lets us predict an object based on its confidence score. I added an extra parameter on a function called target. Target will let us specify on the function which objects we want to detect, either a person or a basketball only. I will then use OpenCV to visually label it on the frame. So as we can see from the result, we are able to detect a person and label it with an outbounding box along with the object label. To represent 3D coordinates on a 2D image, I have created a function that takes in the path of an image and resizes the image. The second function lets us click on the image and returns the corresponding x and y coordinates of where we clicked. The next function then lets us detect and plot the hardlines on the basketball court. Firstly, we are passing our frame to the Kani algorithm. The Kani algorithm results will then be passed on to the Hogline transform algorithm for further detection. So for every line detected on the algorithm, we will be adding and subtracting 1,000 to it. So that when we plot the lines, we will get bigger lines. And then the bigger the lines, the more chances we get of detecting a line intersection between 2 points. Unfortunately, I was having time issues, so I had to move on from this functionality. So instead, I hard-coded 3-dimensional x and y axis just to test the theory concept that I proposed on the 3D to 2D transformation. I can get the matrix value between the 2D and 3D points using a feature matching algorithm or function called find home graph. With the matrix value, I can warp or overlay the 3-dimensional image over the 2-dimensional image, and we should get the following result. Then calculate a mask based on color yellow, and then we can grab the contours based on that mask. And with the contours, We can create an enclosing circle on the detected contours, and that detected contours is the exact position of the player. Now that we are able to detect basketball, detect players, and map player position to a 2D image, the next thing on the line is to classify whether a basketball is a make or a miss. SSIM is basically a measure of the difference between two images. Here I have a function that loads an image to be compared, and sklearn already implemented a function that calculates the SSIM for us, so we just had to import the function. Since we can classify between a make or a miss shot, we can make a score box. Simply create a simple score box in Photoshop and import it into the project. Once our score box is imported, we can simply assign the region of interest on the frame equals to the score box. When the scoreboard is finally on the frame, we can use OpenCV to display the text or the score for us. The score will come from the input parameters on the function called make and miss. Now all we have to do is create an if statement that if the value of the SSM is over than 0.9, then that is equals to a score. And we basically increment the score. I created a CNN model to classify between a basketball and a basketball hoop. I created a sequential or linearly stacked CNN model with an activation call of ReLU. ReLU is a piecewise linear function that outputs the input if positive, 0 otherwise. The data used to train the model is labeled as follows: 0 for a basketball and 1 for a hoop. So I needed a binary activation function such as sigmoid that will output 0 and 1. I only trained the model 8 times to avoid overfitting, and also because epochs of value 8 gave me the best accuracy. So I have joined all of the inner functions to provide us with the following output. Here we are able to detect the basketball, detect the player, and provide the scoring system. Then on the right side, we can see the position of the player on a 2D map. One of the main issues when using object detection algorithm is that it is so slow and that it is resource intensive. So I decided to build a 4-page web app in Electron.js to showcase the different functionalities that my app offers. Conclusion: in terms of computer vision, OpenCV lessens the code that we write using its built-in functions, and it will only get better in the future. Data decisions in sport will continue to grow as more smarter technologies emerges. Object detection algorithm, especially requires a lot of PC power and requires a lot of GPU power.